Somewhere in the vast cold quiet of the Milky Way, something enormous is drifting through the dark, a force so powerful that it bends space itself, warps time around it, and consumes everything that gets too close. And yet, it makes no sound, no light, no warning. It's real. It's moving. And it's completely terrifyingly invisible. It doesn't need to chase. It doesn't need to threaten. It simply moves, and whatever lies in its path will vanish. This is not science fiction. This is the documented reality of our galaxy, rogue. Black holes, cosmic predators untethered from any star system, wandering alone. In 2022, for the first time in history, NASA confirmed one. They didn't see it. You can't see these things. Not directly. They knew it was there because it bent the light of a star behind it, a microscopic ripple in spacetime, caught by the Hubble Space Telescope. During a rare microlensing event. It was given a catalog name, OGLE 2011 BLGO 462, a 7.1 solar mass black hole wandering alone, a rogue. It's not just this one. Astrophysicists estimate that over 100 million black holes drift through the Milky Way, remnants of ancient stars that died, collapsed, and were violently flung from their stellar families. Some are just drifting through the outer spiral arms of the galaxy. Others, perhaps, are much closer. That's what no one wants to say out loud. See, black holes don't glow. They don't pulse. They give off no electromagnetic radiation unless they're actively devouring matter. Rogue black holes, by their nature, are not feeding. They're silent. They're not deadly in the way we imagine threats. They won't explode. They won't chase after us. They don't have to, because if one enters our neighborhood, even by a few light years, it could trigger gravitational chaos across the solar system. Not because it wants to, but because that's what gravity does. And we may not know it's there until after it's passed. Imagine this. You're on a still lake, and far in the distance, someone drops a massive stone. You don't see the splash. You don't hear the noise. But moments later, a wave reaches you, silent, powerful, and unstoppable. That's how a rogue black hole moves through space. And that's what makes it the ultimate threat. It won't warn us. Even our most advanced telescopes, the James Webb Space Telescope, Gaia, Hubble, can't scan the entire sky in real time. They detect movement. They trace starlight. They infer mass by measuring wobbles. That's how OGLE 2011 BLGO 462 was found. Not by observing the black hole itself, but by measuring the way it distorted the light of a background star. A gravitational lens. That one moment. A 1 in a million alignment. Lasting weeks. And without it, that black hole would still be unknown. Still drifting. Still dark. Now, consider how many others like it have never aligned with a background star in just the right way, at just the right time for us to detect them. That number could be terrifyingly high. And what's more unnerving, we're not even looking at the entire sky at once. We never have. No telescope has that ability. So the real question becomes, how many rogue black holes are passing nearby? Completely undetected? This is the essence of existential fear, not what we can see, but what we can't. Not the loud threats, but the ones that creep silently across the cosmic fabric. It's one thing to fear what's dangerous. It's another to realize that you may never see it coming. We live in a bubble of light and order, orbiting a quiet star, shielded by a delicate balance of gravitational harmony. But that harmony can be shattered silently by a passing ghost. With mass 10 times the sun, bending spacetime itself, you won't see it in the sky. You won't feel it coming. And yet, it's there, somewhere in the dark, moving. We're used to imagining black holes as monsters locked at the centers of galaxies, spinning, feeding, anchoring entire star systems like gravitational gods. And for the most part, that's true. Not all black holes stay where they were born. Some escape. These are not mythological beasts chained in the dark. These are runaways. Stellar mass black holes, created in the violent deaths of massive stars, ejected from their birthplaces by forces strong enough to rip gravity itself apart. These are rogue black holes, and they are not theory. They are not hypothetical. They are real. And they're moving through our galaxy right now. A rogue black hole is a black hole that travels freely through space, no longer bound to any star system or galactic nucleus. It's not tethered to a gravitational anchor. It's alone drifting through the Milky Way, like a silent bullet. Most black holes we've confirmed sit at the center of galaxies like Sagittarius A*, our own supermassive black hole. We've observed its motion indirectly by watching stars like S2 whip around it at millions of kilometers per hour. That's how we know it's there. But a rogue black hole? That's a different challenge entirely. It doesn't stay in one place. It doesn't emit light. It doesn't feed off nearby stars to produce X-ray flares. And that makes it nearly undetectable. It's a paradox. A cosmic object so massive it can bend space-time, yet so hidden. It can drift for eons without ever being seen. But in 2022, for the first time, one was caught. It happened by accident. A team led by Kailash Sahu at NASA was using the Hubble Space Telescope to monitor gravitational microlensing events. Rare alignments where a foreground object bends and magnifies the light of a background star, like a cosmic magnifying glass. One of those alignments behaved strangely. The star's light didn't just brighten, it shifted, warped, distorted in a way that suggested more than just mass. It hinted at an invisible body with no light, no radiation moving across the field. Further analysis revealed the culprit, a 7.1 solar mass black hole, alone, moving through the galaxy at roughly 45 kilometers per second. It was given the catalog ID Ogle-2011-BLG-0462. But labels mean nothing to space. This was a rogue, a stellar remnant without a home. It's important to understand what that means. This black hole is not orbiting anything. It's not radiating like a quasar. It's just moving through the stars, across the spiral arms of our galaxy invisibly. If it hadn't aligned with that background star at the exact time Hubble was watching, we would never have known it existed. And how many more are there right now doing the same thing? Scientists estimate that the Milky Way could contain over 100 million stellar mass black holes. Most of them are invisible. Many of them are no longer part of binary systems or clusters. They're just out there. Think of it like this. The Milky Way is a cosmic ocean, and black holes are submarines with no sonar. We don't see their wake. We don't feel their presence unless they pass close enough to disturb the gravitational waters around them. And rogue black holes don't need to collide with something to cause damage. Their gravity alone is enough. If one passes through a planetary system even from a distance, it can distort orbits, eject planets, destabilize entire stellar neighborhoods, all silently. We don't know how many are close. We can't track them in real time. Our only hope is microlensing the brief chance alignment of a dark object with a background star. These events are rare and fleeting, which means most rogue black holes will remain forever unknown, and that's the psychological truth at the heart of this. We now know they're real. We've seen one briefly, accidentally, and only because nature gave us a perfect cosmic alignment. But how many more are passing undetected? How many are drifting through star clusters, brushing past habitable systems, altering their futures, without ever being noticed? How many are already near us, but have never crossed the right line of sight? This isn't an idea from science fiction. This is the natural outcome of how stars live and die. Some stars explode violently, flinging their remnants across the galaxy. Some black holes are ejected from galactic centers during collisions. And some are just lost. Rogue black holes are the aftermath of cosmic violence. They are the wanderers, the invisible weights threading silently through the fabric of space. They have no home, no glow, no voice, but they move. And that's enough to make them dangerous. A rogue black hole isn't born in peace. It's the child of catastrophe forged in one of the most violent processes the universe allows, and then rejected by its own cosmic family. You might think the universe is calm stars and elegant spirals, galaxies slowly dancing. But beneath that harmony is chaos, motion, violence, betrayal, and sometimes even exile. So how does a black hole become a wanderer? It begins with death. Specifically, the death of a massive star. When a star 10, 20, or 30 times the mass of our sun exhausts its nuclear fuel, its core collapses. Gravity takes over. The outer layers explode outward in a supernova, a blast so powerful it outshines entire galaxies for a brief, blinding moment. But here's what most people don't realize. Supernovae are rarely symmetrical, like a hand grenade. Going off inside a watermelon, the explosion doesn't expand evenly. It's chaotic, jagged, lopsided. One side might expel more mass. The other might collapse inward faster. That asymmetry creates a powerful recoil, a cosmic kick. It's called a natal kick, and in some cases, it's enough to hurl the newborn black hole away from its birthplace at speeds of hundreds of kilometers per second. Harvard-Smithsonian astrophysicists, in detailed simulations, showed that this chaotic ejection isn't just theoretical. It's inevitable. Their models revealed that some black holes receive such immense kicks after supernova, they become completely unbound from their star clusters and begin drifting alone through the galaxy. This isn't a rare glitch. It's nature's rulebook. Some of these black holes were once part of binary systems paired with another star, orbiting peacefully, bound by gravity. But when the more massive star explodes and becomes a black hole, the violent asymmetry can tear the system apart. The black hole gets flung in one direction, the surviving star in another. This is how the galaxy gains a runaway monster, one that travels in silence, with no orbit, no radiation, no signal. And the violence doesn't end there. There's a second path to becoming a rogue, gravitational ejection. In dense stellar environments like globular clusters or the crowded centers of galaxies, black holes interact gravitationally. And those interactions are anything but gentle. Picture a crowded dance floor of black holes, stars and neutron stars, each tugging on the others, exchanging energy, spinning unpredictably. Sometimes, a binary black hole system encounters a third object. Through complex gravitational dynamics, one of them gets flung out, slingshotted into interstellar space. It's chaos governed by pure gravity. No friction, no resistance, just motion and mass. In 2020, ESA's Gaia mission released data showing unusual stellar motions that didn't match expected orbital dynamics. Some of these stars were likely former companions of black holes suddenly freed, their paths distorted by the invisible recoil of an ejection event. These ghost trails are evidence. We're not watching the black holes directly, but we see the aftershocks of their escape. And sometimes, galaxies collide. When two massive galaxies merge, as the Milky Way and Andromeda are expected to in about 4 billion years, their central black holes spiral together. As they approach each other, smaller black holes in orbit can get violently ejected due to the chaotic tidal forces. That's another source of rogue black holes. Exiled not just from a system, but from a galaxy. These aren't science fiction plots. They're real. The universe makes orphans of gravity, more often than we ever imagined. And it's important to understand what that means. These black holes aren't malicious, but they're unpredictable, unbound. They don't orbit. They don't radiate. They don't reveal themselves unless they pass close enough to distort the stars behind them. And that's exactly what happened in 2022 when NASA's Hubble telescope observed a gravitational microlensing event. The culprit was a rogue black hole, drifting in isolation through the Milky Way. It was the first direct detection of such an object. One of potentially millions. That's the psychological truth. Nothing in the universe is truly stable. Stars die. Gravity breaks systems. Orbits unravel. And from that entropy, monsters are born. Not just black holes, but homeless ones. Stripped of their context. Moving blindly through space, indifferent to what they pass. A rogue black hole is a product of cosmic trauma. A reminder that beauty in the universe is often sculpted by destruction. It doesn't need to hunt. It only needs to move. And somewhere out there, it is. We used to look at the night sky and feel safe. Stars, twinkling. A quiet, empty canvas. Space, they told us, is mostly void. But that was an illusion, the kind of illusion born from distance and darkness. Because the truth is far more unsettling. Space is an empty dot, it's crowded dot, and many of its most dangerous. Travelers are invisible dots, so how many rogue black holes are out there? Not one, not dozens. Not even thousands. The latest astrophysical models, grounded in decades of observation, data from NASA, the European Space Agency, and theoretical work from institutions like Harvard, suggest a staggering number. There may be over 100 million black holes in the Milky Way galaxy alone. Let that sink in. That's more black holes than there are people in most countries on Earth. And here's the truly terrifying part. Many of them are rogues, not orbiting anything. Not anchored to a star system. Just drifting. Free. Unseen. Imagine a vast cosmic minefield, invisible, scattered across every quadrant of our galaxy. You can't see them. You can't predict them. And most of the time, you don't even know they're there until it's far too late. We know about these black holes, not because we see them directly, but because of the mathematics of death. Astronomers estimate that 1 out of every 1,000 stars, massive enough to die in a supernova, leaves behind a black hole. Multiply that across the 200 billion stars in our galaxy, and the number becomes overwhelming. And remember what we've already learned. Death in space is rarely quiet. When stars explode, their black hole remnants can be violently ejected. Over billions of years, through stellar collisions, binary disruptions, gravitational slingshots, and galactic mergers, these remnants are set loose. A study led by Kailash Sahu at NASA's Goddard Space Flight Center used gravitational microlensing, the warping of background starlight, to detect an isolated rogue black hole. Just one. But that detection opened the floodgates, because if we caught one purely by chance, how many more are lurking in the dark? That one rogue black hole, observed in 2022, was drifting 5,000 light-years away. It had no visible radiation, no companion star, no X-ray glow. It was only noticed because its gravity distorted the light of a star behind it, a cosmic fingerprint left in passing. This technique, gravitational microlensing, is currently the only way we can detect isolated black holes. But it's rare. It requires perfect alignment between a distant star, a black hole, and Earth. The odds are microscopic. Yet we still found one. That implies there must be many more. Think about that. If your eyes could see gravitational warping instead of light, if you could see the invisible, the sky wouldn't look peaceful. It would look infected. Tiny warps, twists in space, trails of gravity crisscrossing the galaxy. Black holes moving quietly, alone. The ESA mission, which tracks the motion of over 1 billion stars, has detected anomaly stars being tugged subtly off course, moving in ways that suggest nearby, unseen masses. Some of those are likely exoplanets. Some are brown dwarfs, but some are rogue black holes. And Gaia is helping us follow their footprints. Astronomers believe that up to 10% of the stellar mass black holes in the Milky Way could be rogue. That's millions. Now look up again. The darkness between stars isn't empty. It's full of them. Objects that don't shine, don't pulse, don't speak. Just move. Imagine a jetliner flying through the night with no lights, no radar signature, and no warning system, and there are millions of them. That's what rogue black holes are to the galaxy. And we live inside that galaxy. It's like living in the ocean, but being told that sharks are rare. Until you find out. There might be 100 million. That's what this discovery does to the human mind. It flips our sense of safety. We once thought the Earth moved through a serene void. But now we know space is a jungle. And something is moving through it. Cold, silent, real. They're not myths. They're not rare. They are everywhere. Let's imagine the worst-case scenario. A rogue black hole, silent, massive, invisible, is moving through space at hundreds of kilometers per second. It's not heading toward us directly. Not yet. But it's close enough that its gravity is already nudging the stars in our neighborhood, distorting orbits, altering trajectories we once thought were stable. And we have no idea it's coming, because detecting a rogue black hole is like trying to find a sniper in total darkness, a sniper that doesn't breathe, doesn't move predictably, and leaves no sound behind. So can we detect them in time? The answer scientifically is yes, but practically, emotionally, existentially? That answer becomes much more disturbing. The blind spot of astronomy. We've built telescopes that can see galaxies billions of light years away. We've photographed the afterglow of the Big Bang. We've watched stars being born in the infrared haze of nebulae. But a black hole that's just a few thousand light years away, moving silently through the dark? That's a different kind of problem. Rogue black holes emit no light, no heat, no radiation unless they're actively devouring matter. And most of the time, they're not. They drift through the interstellar void, far from gas clouds, far from stars, far from anything they could feed on. In visibility terms, they're the ultimate stealth weapon of the universe. So how do we even know they exist? The key is gravity. MICROLENS. Shadows in the starlight. In 22, a team at NASA led by astrophysicist Kailash Sahu confirmed the first isolated stellar mass black hole using a phenomenon called gravitational MICROLENSING. When a black hole passes precisely in front of a background star, its gravity bends the star's light, not unlike how a lens bends rays in an optical system, but unlike a glass lens, this one is invisible. It doesn't focus the light into a sharp image. It distorts it, slightly brightens the star, delays the light, and then lets it return to normal after days or weeks. We don't see the black hole. We see its effect. Think of it like this. You're watching the candle flicker in the distance. Then, for just a moment, a hand passes in front of it but not close enough to block the flame. Instead, the light wobbles slightly. Just barely. That wobble is all we get. These events are so rare, so fragile, that catching even one is like winning a cosmic lottery. It requires perfect alignment. The rogue black hole, a background star, and Earth, all in a straight line. And yet, we caught one. That means they're definitely out there. But here's the terrifying catch. Microlensing doesn't give us warning. It's reactive. By the time we detect the signature, the object is already long gone. It's like noticing a bullet hole after the shot's been fired. Gaia, following the ripples. There is one mission, however, trying to do better. Trying to see before it's too late. ESA's Gaia spacecraft is mapping the motion of over 1 billion stars in the Milky Way in extraordinary detail. It doesn't look for black holes directly. Instead, it looks for stars that are being subtly pulled like puppets on invisible strings. Some of these stars have no visible companion, yet their motion is being altered, slightly, persistently. This isn't random. This is gravity. Something massive, something invisible, is pulling on them. These astrometric wobbles are one of our best hopes. Gaia's long-term mission is like listening to the entire galaxy and trying to hear footsteps in the silence. And slowly, It's working. Several candidates have been identified massive, dark, gravitational anomalies that may be rogue black holes. But even Gaia has limits. It takes years of data to detect motion changes. And the closer a black hole is, the less time we have before it becomes a problem or a catastrophe. The window of warning. The cold reality is this: by the time we know a rogue black hole is close enough to matter, it might already be too late to do anything about it. No heat signature, no light trail, no radar ping. If it's passing near the Oort cloud, the icy edge of our solar system, we may detect some gravitational distortion. A few comets pulled off course. A wobble in outer planetary orbits, but that's subtle. And the time between possible detection and gravitational chaos could be measured in decades. Or just years. And if it's heading closer, if it crosses the heliosphere, nudges the orbit of Neptune, or pulls Earth just slightly off its path, the effects could be catastrophic. And we might only understand what's happening after it begins. After the skies shift, after the tides surge, after the orbits falter. We like to think of technology as our shield, that we'd see danger coming. But when it comes to rogue black holes, we're almost blind. And the scariest threats are the ones you never see coming. It doesn't have to collide with us. It just has to pass by. That's the silent horror of rogue black holes. They don't need to make contact to cause damage. Their influence invisible, untouchable, unstoppable is written in the laws of gravity. So let's imagine a scenario. Not science fiction, not a Michael Bay movie, but something simulated, calculated, published by Harvard, by NASA, by the University of California. A black hole 10 times the mass of the sun drifts silently into our galactic neighborhood, not into the solar system, just near it. Let's say within 1 light year. That's about 9.5 trillion kilometers. Far in human terms, but in gravitational terms, close enough for things to begin unraveling. The first to fall. The Oort cloud. At the very edge of our solar system lies the Oort cloud, a spherical shell of icy objects, comets, and debris orbiting the sun from 2,000 to nearly 100,000 astronomical units away. It's like a cosmic minefield, dormant until disturbed. If a rogue black hole passed even 1.5 light years from Earth, its gravity would ripple through this frozen frontier. Simulations from Harvard astrophysicists show that even a modest gravitational tug could destabilize tens of thousands of objects in the Oort cloud. Each one of those icy bodies could become a bullet. And Earth? It sits in the crosshairs. A slow-moving black hole could trigger comet showers, thousands of years after its pass, long after we've forgotten it ever came. But if it's faster, a brief, sharp encounter, the window tightens, centuries, or just decades, before the sky begins to fall. Then, the planets shift. Let's say the black hole comes closer. Within 0.5 light years, about 30,000 astronomical units. That's still 7 times farther than Pluto. But at that range, things begin to bend. Not break, not yet. Pluto's orbit stretches. Then Neptune's. Then Uranus. According to a 2020 study from the University of California, a flyby, even at this distance, could elongate planetary orbits and introduce chaos into the gravitational balance of the outer solar system. Imagine Jupiter, the guardian of Earth, having its orbit subtly shifted. Not enough to notice in a day, but enough that, over centuries, its protective effect weakens. That means more asteroids slipping past, more debris raining inward. The inner planets Mercury, Venus, Earth, Mars begin to feel the echo. And here's the part that triggers dread. We wouldn't know it was happening. Not at first. There'd be no fireball, no explosion, no flash in the sky, just the math wouldn't add up. Planets would no longer move exactly where we expected. Comets would appear from unexpected vectors. Orbital predictions would begin to fail. We'd realize too late that something massive and unseen had passed. US.Earth doesn't have to be hit to be destroyed. What if the black hole never comes closer than 1 light year? We survive, right? Maybe, but the Earth's climate, tides, magnetic field, all of it depends on delicate gravitational relationships with the moon, the sun, and the balance of the entire system. Break that balance, and we're not living in the same world anymore. Worst case scenario, a near flyby could even eject Earth from its orbit. Not instantly, but slowly, invisibly. A fractional distortion, calculated in decimals so small, they don't even register. In everyday experience until centuries later, when Earth is no longer orbiting the sun in a stable path, and what happens to a planet untethered from its star? It freezes. The atmosphere collapses, the oceans solidify. Civilization ends not with a bang, but with a slow, silent drift into darkness. This is the dread science doesn't comfort us from. No defense system. No warning alarm. No missile shield. Just gravity. Just the ancient physics of mass and momentum, operating on scales and timelines so vast that by the time we fully understand what's happening, the cascade has already begun. And that's the truth. The black hole doesn't need to touch us. It doesn't even need to glance our way. It just needs to exist near enough to whisper to the solar system. And when gravity whispers, everything listens. The absence of evidence is not the evidence of absence. Carl Sagan. We fear the future. We dread what a rogue black hole might do. But the truth is more disturbing, because it may have already happened, not once, but several times, and we're only now piecing together the cosmic scars. The hypothesis of Planet 9. At the outermost edges of our solar system, something strange is happening. Several distant objects like Sedna and 2012 VP113 follow elongated, tilted orbits. They don't behave like anything else in the solar system. They're not shaped by Neptune. They don't loop like traditional Kuiper belt objects. Instead, they move as if pulled by something massive, something invisible. This led scientists from Caltech, including Dr. Konstantin Batygin and Dr. Mike Brown, to propose a new hypothesis in 2016, a ninth planet, roughly 5 to 10 times the mass of Earth, orbiting far beyond Pluto, too far and too faint to see, but heavy enough to warp the orbits of multiple celestial bodies. Planet 9. But here's the twist. Not everyone believes it's a planet. Some suggest it was never bound to the sun at all. Instead, it could be a rogue black hole, a remnant from an ancient stellar death, captured temporarily, or merely passing through, leaving gravitational chaos in its wake. A 2020 preprint from Harvard's Avi Loeb even suggested the use of microlensing surveys to search for such black hole candidates in the outer solar system. So we must ask, what if Planet 9 isn't a planet, but a ghost? Sedna, the smoking gun. Sedna is one of the coldest, most distant objects we've ever found. Its orbit takes it as far as 937 astronomical units, nearly 31 times farther than Neptune. But it doesn't just orbit far. It orbits wrong. It's perihelion. The closest point to the sun is still far beyond the influence of Neptune, and its orbit is highly elongated, taking over 11,000 years to complete a single revolution. Why? The best explanation isn't the planet. In 2004, a study in the Astrophysical Journal Letters proposed that Sedna's bizarre orbit could be the result of a close encounter with another star or massive object, perhaps a rogue planet, or more ominously, a stellar mass black hole, passing within 1 to 2 light years. That may have happened during the solar system's infancy, when it still existed inside a dense stellar nursery. But the effect remains, a gravitational fingerprint, a signature of disturbance. Ancient disruptions and the death they might have brought. It gets worse. Studies of the fossil record have revealed periodic mass extinctions on Earth. Every 2630 million years, life is suddenly cut down. Extinction pulses. Like clockwork. One theory? A massive object orbiting the sun in a long eccentric path periodically disrupts the Oort cloud, flinging comets inward. This object was once nicknamed Nemesis, a theoretical companion, star or planet that could trigger deadly comet showers. Now, the idea of Nemesis has largely faded. But the core idea remains. A rogue object, orbiting or drifting through, can reset the sky. And the death that falls from it takes no prisoners. Imagine a black hole passing by the solar system 70 million years ago. Too far to destroy Earth, but close enough to destabilize the Oort cloud. Within a few million years, a window consistent with orbital mechanics. Comets begin to rain inward. One of them strikes Earth. Chicxulub, the dinosaur killer. Coincidence? Perhaps. But the timing is suspicious. Signs of a visitor long gone. The solar system holds structural anomalies that don't add up. Planets tilted slightly off the sun's equator. The ecliptic is not perfectly aligned. The sun itself wobbles with a periodicity we don't fully understand. One explanation? An ancient gravitational encounter. A rogue black hole a passerby could have come close billions of years ago. During the early days of planet formation, it would have bent the solar system slightly, out of shape, then drifted off into the dark. We'd never know. Except for the broken symmetry it left behind. What if we've already been touched? We tend to believe our solar system is a sealed system, self-contained, safe, predictable. But every shred of evidence suggests the opposite. Sedna moves like it was thrown. Distant objects orbit something that isn't there. Planet 9 might not be a planet at all. Mass extinctions follow a suspicious rhythm, and ancient distortions hint at a visitor we never saw, but still feel. So now we must ask the question that science can't fully answer. What if it already found us? What if we were already brushed by the void? And the scars of that touch are written in the structure of our solar system, and the bones of species that never survived to tell the tale. The past is not as still as we think. The rogue does not announce its arrival, and it does not apologize for having been here. We like to think of the night sky as stable, that the stars remain fixed. The galaxies slow dance across eternity, and the cosmos drifts in stillness. But this is a lie told by perspective. The truth is far more unsettling. The galaxy is not a calm sea, it's a storm. And it's only getting worse. Let's zoom out, because while a single rogue black hole could annihilate our solar system, there's a larger stage where chaos brews. A future we can't escape. One that rewrites the structure of the galaxy itself. The Milky Way is on a collision course. We are inside the Milky Way, a vast spiral of 200 billion stars. And just 2.5 million light-years away, another spiral galaxy spins silently toward us. Andromeda, it's visible in dark skies with the naked eye, a faint blur. What most people don't realize, that blur is moving toward us at 110 kilometers per second. That's over 390,000 kilometers per hour, according to precise measurements from the Hubble Space Telescope and ESA's Gaia mission. The two galaxies are expected to collide in about 4.5 billion years. Not a gentle merge, but a cosmic cataclysm. So what does it mean when two galaxies collide? Not stars crashing into each other, the distances are too vast. But gravity doesn't need contact. It needs mass and motion. And both galaxies have plenty. Each one holds supermassive black holes at their centers, over 4 million solar masses in the Milky Way, and even more in Andromeda. When the galaxies begin to merge, they won't simply combine. They'll distort, they'll shred spiral arms. They'll fling stars and black holes in every direction. A 2022 simulation from NASA's Goddard Space Flight Center shows that the merger will trigger massive gravitational waves of disruption enough to hurl dormant black holes out of stable orbits and into the galactic halo. Some of those will become rogues. The birth of rogues. Black holes. don't drift out of galaxies by accident. They're launched, recoil events, violent reactions when black holes merge can send them careening out of the galaxy at thousands of kilometers per second. We've seen it. The Chandra X-ray Observatory and Hubble captured one such event in the galaxy CID 42, where a black hole was likely flung from the galactic core at over 5 million kilometers per hour. Another candidate? A wandering black hole discovered by Gaia and Hubble in 2022, drifting silently through the Milky Way, completely detached from any visible system. These are the runaways. And when the Milky Way and Andromeda collide, simulations show this will not be rare. It will be common. Thousands of stellar mass black holes, dozens of intermediate mass black holes, and possibly even supermassive black holes, all unleashed into chaotic, unpredictable orbits. A galaxy in turmoil. The merged galaxy, sometimes called Milkrometa, will look nothing like either of its ancestors. It will be bloated, chaotic, swirling, with gravitational tides that destabilize systems, eject stars, and scramble orbits. Stars like our sun could be pushed into new regions of space, or hurled into the void. Worse, the stellar graveyard will be disturbed. Black holes that have rested in silence will awaken, dislodged from their ancient positions, set adrift in unstable vectors, some toward the edge of the galaxy, some inward, some toward us. And here's the psychological turn. The process doesn't wait for the collision. It's already begun. Gravitational effects of the approaching Andromeda galaxy are already detectable in the velocities of local stars. Minor turbulence is increasing. And as the galaxies draw nearer over the next few billion years, the rate of orbital disruption will rise. We are living inside a loaded gun, slowly cocking itself. This is not hypothetical. It's not science fiction. It's physics. It's orbital mechanics. It's observation, simulation, prediction. We have seen galaxies collide. We have mapped the chaos. We have watched rogue black holes be born from galactic war. The universe isn't safe. It is becoming more unstable, not less. More violent, not gentler. The future doesn't just hold potential danger. It holds statistical certainty. And when those black holes are unleashed, thousands of them, some will find stable orbits. Others will drift between stars. And a few will become the monsters we dread, invisible, undetectable until it's too late. Traveling through the dark, slingshot by galactic violence we never saw coming. So yes, a rogue black hole might be heading toward us. But that's not the worst part. The worst part is that the galaxy is about to create thousands more. And there's nothing we can do to stop it. The idea of a rogue black hole finding us sounds like a death sentence. Unstoppable, invisible, inevitable. But is it? Is there anything at all humanity could do to prepare for such a cosmic assassin? It turns out, there may be, not with certainty, not with strength, but with vigilance, with foresight, and with the humility to accept how fragile we really are. Let's walk that tightrope between terror and a sliver of hope. Detection. Seeing the invisible. First, the obvious challenge. Black holes do not emit light. They don't glow. They don't shimmer. They swallow light, bending and breaking space around them like a lens of darkness. A rogue black hole would drift through interstellar space, undetectable by traditional optical telescopes. But there are tools, crude, fragile, but promising. One of them, gravitational microlensing. It works like this. When a black hole passes in front of a distant star, the light from that star bends slightly, not because the star has changed, but because the black hole's mass warps spacetime itself. It creates a temporary brightening, a blip. A blink. This is what led NASA and ESA's Hubble and Gaia teams to discover a possible rogue black hole in 2022. A 7 solar mass object drifting freely in the Milky Way. No visible star. just its gravitational shadow. But here's the problem. Microlensing is rare. It requires perfect cosmic alignment, like threading a cosmic needle across trillions of kilometers. And by the time a black hole gets close enough to trigger microlensing near Earth, it may already be too late. Cosmic early warning systems. So we look for other options. Could we build a black hole early warning system? That's where the Gaia mission comes in. Gaia is a European Space Agency observatory tracking the precise motions of over 1 billion stars. Not their light, their movement. Because if something invisible disturbs that movement, a star suddenly shifts or veers off course. That could mean something massive and dark is nearby. Avi Loeb, astrophysicist at Harvard, has proposed the concept of cosmic preparedness, not just reacting to threats, but actively building systems to detect them decades or centuries in advance. Think of it as a gravitational radar system, one that watches for patterns of disturbance across the galaxy. We aren't there yet, but we've started, and that might matter. The impossible escape. What if detection worked? What if we spotted a rogue black hole far enough in advance? Say, 10,000 years away. Could we survive it? That's where things get even more speculative, but not entirely impossible. Enter breakthrough. Starshot, a real-world project backed by scientists like Avi Loeb and Stephen Hawking. Its goal? To send microprobes to Alpha Centauri, the nearest star system, using laser-powered light sails. Tiny, fast, unmanned. But the concept matters. Because what if this technology, scaled over millennia, allowed us to send not probes, but people? Theoretical megastructures, like generation ships, could house thousands. Nuclear propulsion. Artificial biospheres. Interstellar exodus. It sounds like science fiction. But the real fiction is believing Earth will be safe forever. Rogue black hole doesn't need to collide with us. It just needs to pass nearby, disturbing orbits, hurling comets, breaking the balance that keeps our world stable, if we detect it soon enough. And if our technology evolves, escape might not be a fantasy. It might be a necessity. But here's the raw truth. None of this is fast. None of it is guaranteed. Detection requires luck, alignment, and global cooperation. Escape requires a technological leap orders of magnitude beyond anything we've built. The reality? If a rogue black hole were heading our way today, even from several light years out, we wouldn't detect it until the gravitational tides had already begun shifting the solar system's outer edges. The Oort cloud, a spherical shell of icy debris around the sun, would ripple first, silent, unseen. Then comets would rain inward. Orbital paths would start to drift. The system would begin to fracture. By the time we realized what was happening, the countdown would have already begun. The fragile hope. And yet, there is hope in knowing. There is power in awareness. Because every major advance in space science, from Hubble to JWST, Gaia to Starshot, started with a question we couldn't answer, but refused to ignore. We are not powerless. We are vulnerable, yes, but not blind. The universe has no interest in saving us. But we do. And if we listen to the data, if we build with vigilance, if we look to the stars not with arrogance, but with humility, we might see the next rogue black hole before it's too late. We might not stop it, but we might move beyond its reach. That's not fantasy. That's evolution through awareness. Through vision. It doesn't hate us. It doesn't even know we exist. The rogue black hole. It doesn't stalk. It doesn't aim. It simply moves through the dark, through the quiet, across billions of years and trillions of kilometers. And if it were to pass near our solar system, if it were to shred our orbits, erase our sky, or unmake everything we've ever called home, it wouldn't even notice. That's not malevolence. That's the indifference of the cosmos. And maybe that's the most terrifying truth of all. The illusion of safety. We build our lives on assumptions that tomorrow will come, that Earth's orbit is stable, that the night sky is silent and safe, but space doesn't owe us safety. The solar system is not anchored in certainty. It is drifting not just through space, but through a galactic minefield. Every passing star, every rogue planet, every black hole that slips untethered through the Milky Way is a cosmic dice roll. Statistically improbable? Yes, but impossible? Not even close. Harvard simulations and Gaia data confirm it. Our galaxy is filled with hundreds of millions of stellar mass black holes. Thousands of them unbound. Wandering dot right now, one could be moving silently through the dark. 10 light years away, or 2, and we wouldn't know. Not until the damage has already begun. Why don't we think about this? Because our minds weren't built to feel deep time. We evolved to dodge tigers, not tectonic shifts. To find shelter from rain, not gamma ray bursts dot, so we shrink the universe into a sky. We paint it with stars and call it beautiful. But we rarely see what it really is, unforgiving, vast, indifferent. Brian Cox once said, "We are the cosmos made conscious, and life is the means by which the universe understands itself." But that consciousness is fragile, and it's temporary. Rogue black holes remind us we are not permanent. The significance of insignificance. Carl Sagan spoke often of humility. He looked at our planet, that pale blue dot, and urged us to grasp our smallness not as despair, but as perspective. But here's the twist. A rogue black hole doesn't just challenge our physical safety. It challenges our existential arrogance. It reminds us that civilization is a thin skin, floating atop a world balanced by invisible forces. Change those forces, and the skin breaks. All of it, our cities, our books, our dreams could vanish. Without malice, without noise, without a trace, and still, the galaxy would go on, unaffected, unaware. Awareness is our only shield. We can't stop a rogue black hole. We can't redirect it. We can't outrun it, not yet, but we can understand it, and that matters, because awareness is the beginning of agency. We've already built instruments that can sense gravitational shadows, telescopes that detect stars drifting, light bending, timelines shifting. We are watching now, and maybe that's the beginning of something powerful. Not dominance over the universe, but survival within it, because the cosmos doesn't provide warnings. It doesn't announce threats. It doesn't care who's listening. We have to choose to listen anyway. Imagine this. A black hole, 10 times the mass of our sun, drifting toward us at hundreds of kilometers per second. No light, no signal. Just a ripple in gravity. A shadow in motion. It doesn't hate us. It doesn't want to kill us. It simply exists. And that's enough. That's the message. The universe is not a story written for us. We are not its main characters. We are barely a sentence, a flicker in the margins. But in that flicker, we discovered black holes, we mapped galaxies. We launched probes beyond the solar system. We looked into the abyss and we understood something. Even if the abyss doesn't understand us, the universe is under no obligation to make sense to you. Neil deGrasse Tyson. But we try anyway, because it's in the trying and the reaching that we find meaning. Even if a rogue black hole ends our story, we wrote it first. And that is what makes us extraordinary.